So so in order to solve this, we this is 4-5 linear inequalities. Um, we we need to graph it because there's more than one solution. Often, so there's often many solutions. So it needs to be shaded. So we need shading to represent all those points that work. There are often many, many points that work. So for example, where are all the points where the y coordinate is less than -1 times the x coordinate plus 1? So we start by graphing the line. And you know that you're all experts at graphing lines. You would start at the y-intercept of 1, and then the slope is -1/1, so you would go down 1 to the right 1. So do those points work or not? If I plug those points in, would they be less than? They actually wouldn't work if I plug those points in. Therefore, you make a dotted line. I don't want to include anything on there, but since it says y less than, this symbol, remember, it points to the left, it means less than. Any point underneath the line will work. So you shade, and feel free to use colored pencils when you do this. So you would shade everything underneath, and all those points work. So for example, let's try. So my solution means that any point in the shaded region will work in the equation. So let's try a point. So for example, what would be an easy point in the shaded area to try?
0, 0.
Yeah, 0, 0. So for example, 0, 0 is in the shaded region. So if I plug in x equals 0 and y equals 0 into the inequality, it will be true. Let's verify that. So let's try this point 0, 0. Is 0 less than -0 plus 1 question mark? Is 0 less than 1? Yes. So, and that would be true for every point in that region. So now let's try number 2. We have to do a little bit more work because it's not in slope-intercept form. We have to solve for y. So first we subtract 3x from each side. And so you get 2y is greater than equal to -3x plus 6. And then we still need y to be alone, so you divide everything by 2. And so you get y is greater than equal to -3/2 x plus 3. And now we're ready to graph it. It's in slope-intercept form. So you go to 3 on the y-axis, and then you go down 3 to the right 2, down 3 to the right 2. And then is it solid or dotted line? Because of the equal, it's solid, yeah. So the points on this line actually will work because it says anytime you have any sort of equal to, like the line underneath, those will work. And this symbol means greater than, so you go above the line. So everything above the line. How do you figure out where above is? You can pretend like you're a waiter and it's like a tabletop, and where would you put the things to balance them? That's above. Or look on the y-axis. The y-axis, the numbers get greater as you go up, so it's that side of the line. Just follow along the y-axis. Yeah, Selena? Under? Yes. Because if I tried let's say I tried 0, 1 into this inequality, I would go 1 less than -0 plus 1. See how 1 is not less than 1 and it's false? So if I try to plug in any point on the dotted line, I'll get a false answer. And great question. And your solution has to be everything that works. So then for the last one, we're going to have more requirements. We're going to have a system of inequalities where I have to find all the points that work in both of these together. So first I do each one individually. We'll use different colors, and then the overlap will be the solution. Yeah.
This is sort of like a side question, I guess. Does this sort of like with the shaded area still work for like parabolas?
Yes. This-
would it go on the outside and the inside?
Absolutely. This works for nonlinear equations, parabolas, anything. And
For a parabola, would it go inside the
and
negative,
the
or-
way you know for sure which side to shade is just try a point. And if it works, then that's the area you shade. And if it doesn't, then you shade the other area.
Alright.
That's a great question. So we have y less than equal to 3x minus 2. So you go to negative 2, and then you go up 3 over 1, up 3 over 1, and it's going to be solid. And we are going to shade, it says less than, so below. Look on the y-axis and go below. So anything in here will work in the first inequality. Now in a different color, we're going to do the other one. So we start at 4, and then we go down 1 to the right 1. This is going to be a dotted line, and we shade above, looking on the y-axis, we shade above. So that's this way. And so what you can do is wait until the end to do your final shading, but I'll show you in the highlight that the answers are any point in this area is the answer. And you can see it by the overlap in the colors or the overlap in the way, the direction the lines are going. But any point in here will work, or on this line, but not on this line, not on the dotted line.